Hello, everyone out there, and welcome back again to our channel, Tutoring Made Easy. I hope each and every one of you is doing great. The goal of this channel is to make tutoring easy and to help as many people as possible. If this is your first time coming in contact with our channel, I will be grateful if you will subscribe and share it to as many people as possible. If you're already a subscriber, I'd like to use this opportunity to thank you for supporting the channel. If you have specific questions and topics you want us to do a video on, feel free and drop it in the comment section below, and we'll be more than willing to do that for you. Today, in this video, we are going to look at another type of experiment. Previously, we looked at the toss of a coin, tossing it once, and then the possible outcomes and the type of trial that is called. And today, we are going to look at the rolling of a die, the toss of a die or a rolling of a die experiment. Now, if we roll a die once, if we roll a die once, we roll it once, it means we are having what? A single experiment. A single experiment. We are rolling it once. It's a single experiment. Once. But what is the possible outcomes? What is the possible outcomes? So the possible outcomes, right, is going to be what? How do we find that? We say that the outcome of a single trial, outcome of a single experiment or trial, exponent what? The number of trial. So in this case, we are going to have into bracket the single experiment. When you do the single experiment, you're either going to get a die like this, a die. When you roll it, you're going to have maybe 1, 2, 3, 4, 5, and 6 at the top. So it has 6 sides. It has 6 sides. The die has 6 sides. So it can either be 1, 2, 3, 4, 5, and 6. So the outcome of a single trial is going to be 6 outcomes. To the power of 1, the trial is only 1. So we are going to get what? 6 to the power of 1, which is what? 6. So how do we list? So to list the total outcome, list the outcomes, we've already done that. It's actually 1 on the other side, 2, 3, 4, 5, and 6. And remember, this is just a single experiment or trial of rolling a die. You can see clearly here that when we roll the die once, we have more than 2 outcomes. So this cannot be a Bernoulli. It cannot be a Bernoulli trial. But however, we can be able to adjust it to look like a Bernoulli. For example, if you are looking for an event and we say that we want to look at a situation where we roll a die and then the numbers that show up are less than 4. So it's either the numbers are less than 4 or greater than 4. That gives us 2 possible outcomes. And then by adjusting that, we have a Bernoulli trial. But we are not doing that. What we are just sticking by is the roll of a die. If you roll the die once, it's either going to show up a 1, a 2, a 3, a 4, a 5, or a 6. And that is very clear. So it means the possible outcomes is not only 2, it's more than 2. There are 6 possible outcomes. So it's not a Bernoulli trial. Now let's look at a question. Let's say that what's the probability that a 6 shows up? A 6 shows up when you roll up the die. When we look at the possible outcomes, this is the only 6 in there. So it is the number of times a 6 shows up divided by the total outcomes. And to do that, the number of times a 6 show up is this, only 1, divided by the total outcomes, which is 6. This is the total outcomes. So we get 1 over 6 as our answer. If I ask a question, if you see a problem and say, what's the probability that it is greater than what? The probability that the die shows up a number greater than 3 or greater than 2. If it's greater than 2, we were looking for the number of times a number is greater than 2, divided by the total outcomes. So a number that is greater than 2 is 3. Actually, 3 is 4. 3 is greater than 2. The question didn't say greater than or equal. It says greater than 2. So we have 3, we have 4, we have 5, we have 6, divided by the total outcomes, which is 1, 2, 3, 4, 5, and 6. Now the top part, which is the numerator, the 3, 4, 5, and 6, is how many events or outcomes? 1, 2, 3, 4. So it's 4 divided by the total number of outcomes. 1, 2, 3, 4, 5, and 6. 6. We can simplify this because 2 is a common factor. 2 going to 4, 2, and 2 going to 6, 3 times. So our answer becomes 2 over 3. I hope this helps, and it's helping so far. Now let's look at a situation. We are going to look at a situation where we are rolling a die twice. We are rolling a die twice. We are rolling a die. We are rolling a die twice. We are rolling a die twice. We're looking at this outcome. We're rolling a die twice. What does it mean? This experiment is more than one. Is more than one trial. More than one trial. So it is what? 2 experiments. It's 2 experiments that we are conducting. What will be the total outcomes? What will be the possible outcomes? The possible outcomes is a formula, right? We said the formula is what? The number of outcomes. The number of outcomes on a single trial, on a single what? Experiment. The number of outcomes on a single experiment, all to the power of what? The number of trial, or the number of experiment. So experiment and trial, they're the same. So when we roll a die once, we said that it can either show up as a 1, a 2, a 3, a 4, 5, or a 6, and that's 6 of them. So the number of outcomes for just rolling a die once is 6 outcomes. Then that's the formula. To the power of what? The number of trials. We are doing 2 experiments to the power of 2. And that means 6 times 6, which is 36. So there's 36 outcomes. There's 36 outcomes for rolling a die twice. 36 outcomes for rolling a die twice. So what we're going to do is that we can say that this is experiment. This side is going to be experiment. This side is going to be experiment 1. And in experiment 1, we are going to have the number that is showing up to be 1, 2, a 3, a 4, a 5, and a 6. And then we are going to also look at experiment 2 at the top. Experiment 2 at the top. So this first one, experiment 1, is when we roll the die the first time. We roll the die the first time. Sorry. We are rolling it together, right? We are rolling the die twice. Okay, we're rolling the die twice. It's either we roll it together, or we roll the first one and roll the second one. The same thing. The first die. Roll the die. The first one is this one. Sorry. This is the first one. And then the experiment 2 is the outcome for the second, the outcome on the second die. On the second die. Like this. And like that. All right? And when we do that, we're going to have the possible outcome 1, 2, 3, 4, 5, and 6. And so we are going to put in here, we're going to have, if you look at this 1 and 1. So here's going to be 1, 1. This is going to be 1. This one is 1. 1, 2. This is the 2 on top. And then we are going to have 1, 3. That means that the first die here is 1, and the second one is also 1. This here shows that the first die is 1, and the second die shows 2. The next one is going to be the first die is 1, second die is 4. First die is 1, second die is 5. Here, first die is 1, second die is 6. The next thing is that the first die is 2, and second die is 1. First die is 2. Second die is 2. First die is 2. Second one is 3. 2 and 4. 2 and 5. 2 and 6. Like that. The next one, the first die is 3. Second one is 1. 3, 2, 3, 3. I hope you're getting the drift. 3 and 4, 3 and 5, 3 and 6. The next one is going to be 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6. The next one is going to be, I can't use that one. I want to use a different one. So the next one is going to be 5, because the first one here is 5, and then the second one is 1. 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6. The next one is going to be 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. And if you count these outcomes, you will see that it's about 36, because this row is going to give us 1, 2, 3, 4, 5, 6. If you're going to get 6 on this row as well, you're going to get 6 here, 6 here, 6 here, and 6 here. If we add this and this, we get 12. Add this and this, we get 12. Add this and this, we get 12. We add this and this, we get 24. And then we add 12 to, we get 36. So that's where you have it. 36 is the possible outcomes. 36 is going to be the possible outcomes. Possible outcomes. Now we're going to take the probability question itself, the proper probability questions. We can be told, or we can be asked, that what's the probability that we get when you add both of these dice together. When you add them together, you are going to get a number that is less than and equal to, maybe 9, less than and equal to 9. So it's going to be the number of outcomes, or the dice that add up to what, the number of them that adds up to less than what, 9, and we divide by the total number of outcomes. So this event we are looking for, we have to count the number of times we are getting two pairs, the dice, that when we add them together, we are getting the number, the sum of the two of the dice will give us something less than or it is equal to 9. Less than or equal to 9. Less than or equal to 9. Okay, now how do we go about this? If you look at anything that is less than or equal to 9, we are looking at, when we sum it up, we should either get 6. When we sum it up, we should either get what? We should either get 6. When we sum it up, we should either get 7. When we sum it up, we should get 8, or we should be able to get 9. So we are going to look for the numbers that when we add them together, we are going to get either 6, 7, 8, or 9. Or probably maybe 2. Let's start from 2, because we can have the first die being 1 and the other being 1. So it could be 2. So let me take it again. Sorry about that. Sorry for the confusion. If it's less than and equal to 9, then we're looking at 2. When we add, you can get 2, 3, 4, 5, 6, 7, 8, and 9 is included, because it's a less than and equal to 9. Okay, so if we look here, this is the first one. This one is part of it. We add this and this, we get 2. If we add this and this, we get 3. We add this, we get 4, 5, 6, 7. Can you see that? If we come here too, we get it. This one here, that is also part. Is also part. That is part. This is part. This is 8. This is part. This is part. This is part. This is 7. This is 8. This is 9. This is part. This is part. That is also part. But this is not. This is part of it. This is part. This is part. That is part. This is not. This is not. This is part. That. No, and no. How many no's? We can see 1 is here, 2 is here, 3 is there, 4 is there, 5 is here, and 6 is there. So 6 of them is a no. So we're going to take 6 from the possible outcome. So the probability that is less than 9 is equal to 36 minus what? It's going to be 36 minus the 6. And then we divide by the total outcome, which is 36. So we're going to get 30 divided by 36. And there you have it right there. So all you have to do is be looking out for the sum of the dice to be able to solve your probability question. Don't forget the formula. the problem formula. I hope this helps. If it's blurry and it's unclear, I'd like you to take a pause, take a break, go get some water, just take a walk, a little walk, come back, feel refreshed, and you'll see that everything will make sense to you. But at this point, if you haven't yet subscribed to our channel, please do us a favor by subscribing. Please subscribe. If you've already done that and you're a subscriber, we want to use this opportunity to thank you for helping our channel to grow. For helping our channel to grow. And if you have specific topics that you want us to do a video on, feel free and drop it in the comment section below, and we'll be more than willing to do videos on that for you. But at this moment, I'd like to end here. We'll come back again and we'll continue our probability journey, or probably continue our math journey as well. I'll come to you another time. Take care and bye.